Hello everyone, this is Wasim from Edureka and I welcome you all to this session in which I am going to talk about linked list in Python. So let's take a look at the agenda. But before that, if you are new here, don't forget to subscribe to Edureka for more exciting tutorials and press the bell icon to get the latest updates on Edureka. Also, if you're looking for a certification program in Python, the link is given in the description box below. Now let's take a look at the agenda for this session. So firstly, I'm going to explain what exactly is a linked list and how they are different from a list in general. And after that, I will explain how we can implement a linked list using Python. Moving further, I will create a custom linked list as well. And finally, to sum up this session, I'll tell you a little about the advanced linked list, such as a doubly linked list and circular linked list. So I hope you guys are clear with the agenda. Now, without any further ado, let's begin our session. So what exactly is a linked list? A linked list is basically a linear data structure in which the elements are not stored in a continuous memory locations or contiguous memory locations, which basically means that they could be scattered anywhere in the memory, but functions properly because each element actually points to the next element and eventually reaches to a point where the last element does not point to any other element, which also means that it is the end of the linked list. So what I'm saying is, let's suppose we have 10 nodes. Each element in a linked list is called a node. A node will consist of a head and tail. The first node will be the head and the last will be basically the tail. And the elements are known as nodes, which I already told you. And each node will have two attributes. The first attribute will be the data, and the next one actually points to the next node in the linked list, which is pointing to the next node in the linked list. It is almost similar to the list in Python. I mean, some of the functionalities lack in a list though. We're going to talk about that in the next section. And before that, I just want to tell you, like, this is how a linked list actually looks like. So we have all these nodes. The linked list starts from the head. The very first node will be the head. It will have two values, data and the referencing variable, which is pointing to the next node in the linked list. And it will go until it reaches the last node. And in the last node, there will be two reference variables, but one is the data, obviously, and the next one or the other one will not be referencing to any other element, but it will be pointing to null, which means that you have reached the end of the linked list. So this is basically how a linked list works. So let's talk about how exactly a Python list is different than a linked list that we have. So as we all know, guys, Python list is also one of the collection data types. So I've just pointed out a few points which we can compare them upon. So a linked list is basically stored randomly. There is no order to where how it is being stored in the memory. And a list, on the other hand, is stored continuously. And the next point is accessing an element in a linked list takes longer time since it needs to iterate the whole list to get the element. So what I'm saying is, if you want to access a node from a linked list, what you have to do is iterate through the whole linked list. Then only if it matches the node that you want, it will return it. So this whole time or the time complexity is actually bigger or larger than if you compare it to whatever time complexity you will get in the list, where you just give the index number and you will get the value. So that is faster in comparison to accessing the elements. On the other hand, if you perform any operations like insertion, deletion, or update any values in the list, it's basically faster in a linked list because there is an efficiency that it shows the linked list for operations involving insertion, deletions. Because when you delete or update a value in the list, the positions has to be shifted in either directions and it takes away the efficiency from the list. And now the other point is the memory taken by the linked list is larger than the list, obviously because each element is having additional two attributes, which is basically the data and the next. So eventually it takes a lot more memory than if you compare it with the list. It's only because of the additional reference attributes. And last but not least, I want to talk about the memory utilization, which is much more efficient in linked list compared to the list. These are basically the key points where we can compare both list and linked list together. And a linked list usually is preferred over the list because of the efficiency, of course, because it shows a lot more efficiency for performing the operations. Obviously, it's much faster also. So that is why a linked list is preferred over lists. And the other reason to use a linked list is because they are able to implement stacks and queues. Now what I'm saying is stacks and queues is one of the reasons why linked list is used, and it is one of the implementation of linked list. That is why a linked list is preferred over the list. And so let's take a look at how we can implement stacks and queues using linked list in Python. So let's take it up to Jupyter Notebook, guys. I have already opened a new notebook. I'm going to rename it. Let's call it as Python linked lists. So before moving on to stacks and queues, let me just show you a few list operations. So let's say I have a list, let's call it my list. And using the list constructor in the range 0 to 10, or let's not give it any step. So this is my list. Now my list, if I want to add any values, there is one method I can use, which is append. And I'm going to append a value, let's say 10. So now let's print our list and see what changes were done. So using append, I was able to append the value 10 over here at the end of the list. So if I want to add any values at the end of the list, I can use it or do it by using 10. Now let's say if I want to insert some value on a particular index, how do I do that? So for that I can use there is one insert and there is extend also. So if I want to copy another iterator to my list, I can use extend. There is insert. So for insert, I think there are two parameters that we have to use. So first one will be, I think, a value, and the next one is the index. I'm not sure. Let's see. We check once. All right. So first one is the index value, and the next one is basically the value that you want to insert in your list. So this is how we can insert any values inside a list using these two methods. And let's say I want to enter a value at the the starting point of my list every time I want to add any list. There is no function for that, and that is the reason why this is not really preferred for implementing stacks and queues, because there you need FIFO and LIFO approaches. We'll talk about that later on in the session. Before moving on, let me just talk about a few more. There is this remove and pop. So if I write pop, let's see, it has popped 10 out of my list. And if I check my list now, 10 is gone. All right. And now let's remove a value. So let's say I want to remove 10 again and check my list. So 10 is gone. Now the list is back to normal. These are all the operations that we have in Python lists, which we can use to add and remove values from our list. Now moving on to how to implementing a linked list in Python. Stacks and queues are basically why we are using linked list in Python. So to implement stacks and queues, and stacks and queues are nothing but abstract data types that store a collection of elements, just like a list or any other collection, a data type, a dictionary or a tuple or a set. Stacks and queues are also data types, abstract data types. The only difference between the two, the stacks and queues, is that queues actually follow the first in first out approach, and stack follows the last in first out approach. Before moving on to the stacks and queues, let me talk about the deck. All right. So deck is an advanced data structure that we have in collections module. And if you want to know more about what exactly is collections, there is a tutorial we have made on collections. You can check it out. I mean, there are a lot of advanced data structures like name tuple, and there is a lot of chain map that you can learn from. They are very interesting. And similarly, deck can be used to implement a linked list in Python, guys. How you ask is I'll tell you now. But before that, let me just discuss queues and stacks. So I was talking about queues, which follows the first in first out approach. So to understand queues, a queue outside a restaurant is the perfect example. So let's say you're waiting out to eat at a restaurant and there's a long queue. So the best case scenario is whoever is standing at the first the entrance of the queue, or whoever is in the beginning of the queue, will get to enter the restaurant, will treat the restaurant as the data type, and the first person entering is the first person who's standing at the beginning of the queue. And as soon as the restaurant fills out, now let's say this restaurant is full, so the first person who will be going out, ideally in a best case scenario, or if we talk about queues in data structures, will be the first person who entered the restaurant, and that is the first in first out approach. And when it comes to stack is basically last in first out. So if we take the similar example of a restaurant, let's say if I entered the restaurant last, And according to the principle here, if it follows the stack last in first out approach, I will have to leave first, and then after me, whoever had entered before me had to leave after that. So to implement these data structures in Python using deck, what we are going to do here is, let's say I'm going to create a linked list. All right, so this is my linked list. For now it's empty. Now the next thing that I want to do here is I am going to append some value. Since it's a list, of course, so it's going to append values. And to append, let's say I want to append 0. Now my value has a 0 element in the list. Now I want to talk about a few more methods that we have over here, which is append left. So we have append left, there is insert, and there is pop and pop left. So this is the interesting part that I want to talk about. These are the methods that we'll be using to implement stacks and queues. So to just give you a clear understanding, first of all, let me add a few values here. So this is linked list, and I am going to append left, let's say 1, right? So now if I check my list, I have 1 and 0. So what happened is it actually inserted the value from the beginning of the list using append left. So now I will pop a value, right? Wait a second, guys, sorry. So it popped 0, so basically popped the value. All right, we'll just add one more. So we have these 3 values. Now I'll do one thing. Using pop left, it has popped the value from the left side of my list. So these are the functions that we'll be using to implement a stack and a queue. So which basically tells us like we are able to. All right, so pop left and append left. So these are the functions that are additional that we have in the deck, which basically helps us to implement stacks and queues. So let me just take an example to implement a queue where we will try to implement the first in first out approach. So to do that, first of all, I'm going to create a queue and using the deck. All right, so it's created. Now the next thing that I have to do, I'm going to use a for loop here, because for I in range, let's say 0 to 5, we don't want a very big list. And q dot append, we want to append I, and we will print the q. Yes, so let's see the order of how we have added the values inside our queue here. So first one, or the first element to go inside the queue was 0, then 1, 2, 3, and 4. So the first element that went inside the queue is 0, and the last one is 4. So if we want to implement a queue here, what we have to do here is we have to make sure that the first element that is coming outside of the queue is 0, and the last one to come out is 4. So to do that, I will use the pop left method, and I'll just show you how I'm going to do that. So for I in range, now let's just take the range to be length of q. Yes, I'm going to pop the values from left because we want to pop or remove the first value that went inside the queue. And after that, we are going to print q. So as you can see, we had 1, 2, 3, 4. So the first 0 actually went out before that because we are popping the value, and after that we are printing, and then came out first, second, third, and fourth. So this is how I just implemented a queue using deck, which is a implementation of a linked list in Python. So this is how you use a linked list to implement a queue in Python. Now the next thing that we want to do is we want to do the last in first out for stack implementation. So basically what we'll do here is we will add the values using append left, and we will pop the values using pop. Tell you how to do that. So first of all, let me just let's make a stack. Right, so stack is done. So for I in range, let's take the range to be 0 to 5 only. And now what we'll do is we will append left. So if we do append left, okay, I'll just show you guys, and print stack. So the first element that went inside was 0, then 1, then 2, 3, and then came 4. So the last element, so the last value that went inside the stack is 4. So what we have to do here is we have to pop the value which went last. So we have to start from 4. Now we'll do the similar thing that we did for queues. So in range of stack, we are going to pop left and print stack. So that is how I have just implemented last in first out for stack implementation using deck in Python. So this is how we can implement a linked list in Python for implementing stacks and queues data types. So with this, we have completed most of how linked lists are used in Python, because we already have a function, so we don't really need to work really hard to make one of our own. But we can create a custom linked list in Python. So I'm just going to show you a simple example how you can do that. So two things you have to remember while making a custom linked list is that you will have to create a node, and node will have two attributes. One will contain the data, and the next one will contain the reference variable pointing to the next node. And then you'll have to make a separate class for your linked list. So that is what you need to create a custom linked list in Python. Now let's go back to Jupyter Notebook and we'll create a custom linked list in Python. I'll also tell you about how we can add and remove the values from the linked list. And after that, you can just practice on your own and add other functionality to your custom linked list. So you can create your own functions to understand how it really works. So the first thing that we have to do to create our custom list, it's really not necessary to create a custom linked list, since we already have an implementation which I've just shown you. But if you want to improve your programming skills and understand how data structures work, this is one of the best things that you can do. Pick up the already made functions and try to implement the same thing using pure Python. Try to create functions that do the same thing that predefined function is doing, so you'll really understand how it's working. And this is one of the best practices that you can apply to improve your programming skills. And I'll just show you a few operations. So first thing that I have to do is I'll create a class. Let's call it as node, and using the init function, of course. So we'll have data. Yep. Now in our node, we need data which we'll get from the function, and there'll be a next reference variable pointing to, we'll keep it for none. Now comes the linked list. Basically this will be the class. All right, just call it as linked. Another init function here, and in this we just really need head, which is none, of course. Now after that, we need a function to print r. All right, if I just, let's just see if I have any errors. No errors, guys. Yes. So now after this, I am going to have to add a function, of course. Okay, let's just call it as show. Now with this function, the first node will be head, because starting node of the linked list will be the head. And after that, we'll apply a loop. So if it's none, it means it's an empty list. So if it's not none, we are going to print node data, and we are going to assign the next node to node.next. All right, so I'll just quickly explain you what I did here. I created two classes, node and my linked list. So linked list basically has one attribute, which is the head, which I've assigned to none, and node has two attributes, data and next. So data will be getting from when we call the object, and next we have assigned in our show function. If the if the head is not none, we are going to print the data from the node and assign the next node to the current node. So now what I'll do here is I'll create an instance of linked. Yes, no errors. And now I'll create a node, guys. So let's call it as element, for short. And now we'll call a node. This is let's say Edureka. Yes. So there's one more thing that I forgot to do here. We'll keep it for none. And now let's run this. Now we have created our first node. So now what I'll have to do here is I'll have to link or use this to basically point it to our first element. And now I will use link dot show. So we have our first element. Now let's say I want to add another element. What I'll do here is I'll call link dot, wait a second guys, I'll just get element 2 is equal to node. Let's give it a value Python. Yes. So the next point would be to link this to next is equal to element 2. And now, so we have created our linked list and we are printing our linked list as well. And we can use the iterator also. I mean, iterate through the linked list using or creating an iterator or making an iterator from our linked list. To do that, we can use the iter function, but that's a little advanced for now. So now what I'll do is I'll just tell you quickly how you can add an element in the beginning of the list, basically. So to do that, let's create another function here. All right, guys. Let's call it as add, which will be self. And after that, whichever value that we want to add, we'll be passing in the parameter. Now, we'll call this as new node. Now to add the new node inside our list in the beginning, there are two things that we have to keep in mind. First of all, we have to create an instance, let's say called new. We could have done that for these functions as well. And after this, first of all, I will create or point the next value, which will be self.head, because right now the first value at the beginning of the list is the head. First of all, what I'm doing is creating a new node and pointing the new node reference variable to the current head so that it will become the second element and the new element will be added in my list, right? So after that, I have to do nothing. Basically, now self.head will become new node. And that's it, guys. Now if I call, all right, I think. So now I have add. So I'm going to add, let's say, certification. Yes. And link dot show. Voila. So this is how I'm adding a new value using a function which I've just created here. So similarly, you can create a lot more functions, basically to add values at the end of the list, where you have to traverse through the end of the list, create an iterator. So all those things, if you don't know about how to create an iterator or if you don't know how to traverse through a list, you can check out other tutorials that we have on Edureka. And this is all about implementing whatever you have learned so far in Python, and I would suggest that you should do it as an exercise. And before summing up this session, I want to talk about the doubly linked list and the circular linked list. So what exactly is a doubly linked list? Is nothing but an additional reference attribute will be added in the doubly linked list, which makes it possible for the doubly linked list to traverse in both the directions. So in a linear linked list, what happened was we only had two variables, the two attributes, which was data and next, pointing to the next node that we had in the list. But here in doubly linked list, we had two. There is previous and next. So previous is pointing to the previous or the node which came before it, and after that it's pointing to the next one. So basically moving towards both the directions. So it could move this side also, and it could move to the left and right, both the sides. So the advantage is pretty obvious, guys. The two-way traversal, it occupies certainly more memory than on the singly linked list, because of course it has one additional attribute, reference attribute. And one of the applications that we can think about is the navigation. Of course, if we want to go back and forth again and again, this is the best, in any application. If you want to navigate back and forth, go from end to the beginning again and again, doubly linked list is a pretty good idea to do that. Now, talking about the circular linked list. Circular linked list are nothing but, there is only one difference, I think, between singly linked list and circular linked list, which is nothing but, circular linked list, on the other hand, have one slight difference, which is the last node in the list points to, or the reference of the last node will point to the first element of the list, which basically creates a cycle or completes a cycle and makes it a circular one. What we had in singly list was the last element of the node or the last node of the list was basically pointing to null. But here there is no null, reference attribute. It's just pointing to the first node of the list, which is completing a perfect circle and creating a cycle. So this is all about the linked list in Python, guys. If you have any questions, you can mention them in the comment section below, of course. And you can tell us if you want some topic that you want us to cover or some projects that you want us to make for you guys. And with this, we have come to the end of the session. And alright guys, if you are new here, don't forget to subscribe to Edureka for more exciting tutorials and press the bell icon to get the latest updates on Edureka. And if you're looking for a certification program, the link is given in the description box below. See you guys in another video. Thank you and have a nice day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!